All right, here we go, part 2 or 3. We are going to go over rationalizing with fourth roots. Okay, so we have fourth roots. And so our first example, we're going to do the same idea. We've got the simplify roots. Okay, and because this is a perfect fourth, I'm actually just going to write complete the square twice because I need two perfect squares in order to make this a fourth. Okay, and simplify. We've got to continually look at this simplify piece. All right, so let's do an example. Let's do the fourth root of 20 x to the fourth y cubed z squared. Okay, all over fourth root of 12 x squared y fifth z. All right, so the first thing I'm going to do is look at my simplifying. So I do know that these are both fourth roots. So I'm just going to, okay, and then I'm going to start reducing. I'm just going to pull the pieces over here and see what I can do in order to simplify. Okay, so let's see, I can divide by 4. So I get 5 over 3. Okay, here I get x squared in the top. Notice I'm positioning numerator and denominator. Here I get y squared in the bottom, and here I get z to the first in the top. All right, so I'm just going to go ahead and split this up. 5x squared z in the numerator, and 3y squared in the denominator. Okay, so now I'm going to do my rationalizing work. I'm going to bring my denominator over here, and I'm going to try to figure out what I need to put in this box so that when I multiply them together, I end up with two perfect squares. Okay, so over here, this is 3 to the first, and this is y squared. And so I know that the perfect 4, I need 4 of a kind, which means I'm going to need 2 9s because 9 is the perfect square that goes with 3, which means I'm going to need a 3, right, to get the perfect square. And I'm going to need a 9 so that I actually have 4 of them. Okay? Now, y, which is, okay, so y squared, and so I need y squared. That's one perfect square. There's the other perfect square. I'm just going to go ahead and sort of underneath of this, I'm going to write this is 3 cubed, guys, right? 3 cubed, and this is y squared. Look at those exponents. 1 and 3 make 4. 2 and 2 make 4. So now I'm going to come over here, okay, and I'm going to write this in. So I'm going to multiply by the fourth root of, all right, let's do a little extra, okay, 27y squared. That's what it is, 27y squared. Fourth root 27y squared. Notice that 27 is the perfect cube, and then we have one more 3 over here, which makes it the perfect 4. So let's go ahead and multiply these things together. 81y to the fourth, which is actually 3y. Look at that. 1 3 and 1 y come out of the radical. Okay, so let's multiply this together. Fourth root of, okay, yeah, sometimes it's not above me. Yep, 135 x squared, y squared, z. Okay, and then I've already multiplied this together, so it's a 3y. Now, notice that 135. You're thinking it's kind of a big number, but do you have any perfect fours? Well, look at the numbers that you used to multiply it together. I used a 5, okay, right? Look at it. I used 5 times 27, and 27 is only a perfect cube, so there is nothing to simplify right here. Whew, perfect fourth roots. Not all that different, but your numbers are going to get just a little bit bigger. Okay, let's try another problem. Okay, let's try the fourth root of 3y to the 7th over 75y z w cubed. Okay, can I simplify? Now it's already under 1 radical, so I'm going to go ahead and pull these pieces out and just sort of look to make sure it's all simplified. And I do notice that 3 and 75 does simplify to 1 over 25. And this simplifies to y to the 6th, and nothing happens for those other two pieces. So I'm going to go ahead and just 1y to the 6th. Okay, so that's the only thing I have in the numerator. And the fourth root of 25zw cubed. All right. Now, I'm right. I don't have any perfect. Ooh, there it is. I do see one. Okay, so y to the 6th is y fourth y squared. So I am going to take that root out. All right, so we get y fourth root y squared. Okay. And then I'm going to leave the denominator. Okay, 25z w cubed. Okay, now I'm ready to get rid of the radical in the denominator because there's no perfect roots that I can simplify. So I'm going to just copy it over here, and I'm going to look at it to see what can we multiply by in order to make this a rational number with no radicals. All right, so 25 is the perfect square. And so I need another perfect square, which is 25. Okay, look, 25 and 25, those are both perfect squares, so together they make the perfect 4. Okay, so I have one z, means I actually need 3 more of them, okay? Because z to the 4th is the perfect 4. So I've got w3, so that means I need one more w. All right, so let's multiply these two things together. Okay, so first, 25 is kind of a big number. I don't really feel like multiplying it out. I mean, I guess I could. Okay, 625. I could write it as 625. Okay, and I got z to the 4th and w to the 4th. But I'm actually going to try it like this. 5 to the 4th, because I know that this is 5 squared and 5 squared. Look at those exponents. Sometimes exponents are easier in terms of that multiplication that we're doing. All right, so all three of these things are perfect fours. Okay, so that's going to come out as 5ZW. All right, let's multiply. Let's put our little box in here, which is going to be equal to 1. So I've got 25 z cubed w. Fourth root 25 z cubed w. Okay, so that's step 2, right? I got my rationalizing done, got the roots. Now I'm going to multiply straight across. 25y squared z cubed w all over. Okay, so I already did this, so it's 5zw. Now, as I'm boxing this, I am already looking at that numerator. I know that there's no perfect 4s because I already looked at the 25. That's only 5 squared. Nothing else will simplify. Okay, final question. Ooh, final question. Can you tell me what goes in the box in order to rationalize? Hold on, I'm thinking. 18x y squared z cubed w to the 4th. Okay, so that's my question. What goes in the 5th root if I'm going to rationalize? And then a little bit simpler, what goes in this root? Okay. Last but not least, oh, well, guess I gave you that answer. Okay, what would go here? All right, can you figure out what goes in each of these 2 boxes? See you next class.